Good evening, everyone. So let us start today. Uh, Let me quickly introduce myself again. My name is Antoine. I am going to take this course on biostatistics and R, and today we are going to deal with more tests and statistical analysis, especially focusing on correlation and regression. But we'll be finishing off some part that was left yesterday as well. So everyone, please boot up your R Studio and let's get started. I actually cannot see any one of you. Does anyone have any questions from the previous class that they want to ask? Okay. Okay. So last day we were dealing with ANOVA. So I will just quickly recap so that we can go on to two-way ANOVA. So as we are dealing with different tests, we had covered t-test. Next we are covering ANOVA, which is the test that you use to compare means between multiple groups. So the example we are looking at was we are looking at the means of HP, and the differences between the groups are the 4, 6 and 8 cylinder cars. So in ANOVA you just can directly use more than, like, you can compare more than two groups and do it very easily. So the test that we used, function that we used was AOV. We first changed our cylinder variable to factor so that it goes into the function, and the summary was presented very easily as such. So we are actually looking at only this value, which was the p-value for the ANOVA test, and since it is a 3-star significant value, we know that at least two of the groups, the 4-cylinder, 6-cylinder and 8-cylinder cars, differ between each other depending on HP or horsepower. But as I said, ANOVA only tells you if two of them are separate. So it could be 3 groups that you're comparing, 10 groups or 50 groups, but it will not tell you which groups are exactly different. So in order to do that, you have to do something called a post hoc test. So we use the two keys post hoc test, and it was very simple to run, and we ran it and we saw that it now gave us separate pairwise p-value for all the different groups that we are dealing with. And from that we found out that the 6-cylinder and 4-cylinder people didn't have significantly different HP, but the 8-cylinder and 4-cylinder as well as the 8-cylinder and 6-cylinder groups were actually significantly different. And that is what we wanted to find out, that the 8-cylinder cars are highly more, like, hugely more powerful in terms of horsepower as compared to the 4-cylinder and 6-cylinder ones, but the 6-cylinder or 4-cylinder ones are not very different from each other. That was all we wanted to find out using ANOVA. So we have compared the means between the HP of different groups. Next, what if the next question that someone asks you is what what is the dependence of one particular variable on two other variables, for such as, say we are dealing with HP here, or say we are dealing with mileage. What does the mileage depend on exactly? Does it depend on the number of cylinders that the entire car has, or the HP that the car is producing? So in this case you want to figure out the relationship between two independent variables and a dependent variable. So we know that mileage is probably a dependent variable depending on how powerful the car is, which is given by the number of cylinders it has and the amount of HP it produces. The other questions that you can ask is, what is the relation? So does cylinders and HP both play a role towards mileage, or is it that only cylinders is what determines the mileage and not HP? So when you run a two-way ANOVA, you can answer all these questions. So I want to find out if mileage depends on cylinders or the HP or both of them together. If you want to ask such a question, you can use the two-way ANOVA test, which is just the same ANOVA function, and you just have a dependent variable the squiggly line followed by the two variables you are trying to find out. So you guys can go ahead and write this code into your R Studio and see what you get as a result. Tell me when you are done. Did you get what is shown on the screen? Anyone?
Yes, sir.
Can anyone try and explain this to me? That what exactly are we looking at here? It is very similar to what we were looking at previously. Can anyone try and take a guess? What exactly are we looking at here?
Sir, the p-value,
Yeah, so what does the p-value indicate?
three-star significance, three-star significance it is showing.
Yeah. So there are two things that we can know from this. Second, give me 1 second. Yeah. So see, first in this test, and what ANOVA does is that it compares mileage and cylinders. So it has compared cylinders and it has found a 3-star significance. So mileage does depend on the number of cylinders. It related HP, the horsepower, and the mileage. It was not significant. Then it went ahead and checked if both HP and the number of cylinders plays a role, if they together are playing a role or not. And in that case also there was not much significance. So all over it tells you that the two-way ANOVA is telling you that mileage depends on only cylinders, not on HP, and neither on the combination of cylinders or HP. Uh, we can try something else as well. Can anyone guess what would a mileage actually depend on other than cylinders? Like, go ahead and guess. What do you think that mileage depends on other than cylinders in our empty cars dataset? So for our reference, I will show the empty car dataset here again. So this is our empty car dataset. We have a lot of things here: mileage, displacement, horsepower, uh, DRAT, weight, QSEC, and is it automatic or manual transmission? What do you think that mileage will depend on? So we know that it depends on cylinders. What other parameter do you think it will depend on?
Displacement,
Good guess. Let us try. So my question now is, does mileage depend on cylinder and displacement, or either of them, or both of them? That is the question we are asking. And okay, let us run it and see. So here it is. The second one is what we are looking at. You see that the cylinder is still 3-star significance, so mileage depends on cylinders. It also depends on displacement, but here look at this, that both of them together actually have a 2-star significance, which tells us both the combination of cylinder and displacement is important when it comes to mileage. It is not it is individually dependent as well, but also together they are playing a role. So this is the kind of idea you get from an ANOVA test. If there is a relationship between two different groups, or is there a relationship, in case of two-way ANOVA, if there is a relationship between two different variables playing together to affect a third one. Antik is saying, have you recorded yes, I have recorded the previous sessions as well. I have not uploaded yesterday's. I will upload that now. I think the ones previously are all uploaded. If not, please let me know. I will upload them as well. But I believe only yesterday's is not. Okay. So that is ANOVA done. Does anyone have any questions from ANOVA? So this is probably the t-test and ANOVA are probably the ones that you would
Sir,
yes.
sir, could you please explain ANOVA? I can't understand what is it actually.
Oh, oh. So ANOVA, the simplest form of ANOVA, which is the one-way ANOVA. So we have seen t-tests, right? We wanted to figure out if two different groups are actually different or not. So we have used the t-test for that. If we are using finding the difference between two different groups. But what if we want to find the difference? So in the t-test example, we are looking at a 6-cylinder car engine versus a 8-cylinder car engine, and this was our groups, the HP of 6-cylinder cars and the HP of 8-cylinder cars, and we wanted to compare between them. So which is more powerful, the 8-cylinder cars in terms of HP or 6-cylinder cars in terms of HP? ANOVA comes into the picture when you actually do not only want to figure out the difference between two different groups, you want to figure out between multiple, so more than two. So in case you wanted to figure out, no, I don't care about 6-cylinder, 8-cylinder, I want to look at 4, 6 and 8 all together. Or you wanted to not figure out the difference between the marks you got in biochemistry and mathematics, but all the subjects, 10 subjects that you were taking at that same time. So more than one group, more than two groups, if you want to compare, you use ANOVA. The simplest form is something that we had seen in the previous class. We just use the ANOVA function and just declare two groups. So HP was the variable that we wanted to distinguish between, and cylinders was our factor that we were distinguishing between. So 4, 6 and 8 cylinders, so we had three groups, and HP was what we were comparing. And so we ran our ANOVA and saw that we have a significant result. So ANOVA is giving us a significant result, which means the 4, 6 and 8, three of them, at least two of them are different from each other. But which two are different? To figure out, we do a post hoc two keys test, which tells us that the 8 and 4 and the 8 and 6 groups are the ones that are actually different. 6 and 4 are not. This is the simplest one-way ANOVA that we use. Most of the time we will be using this. Is this fine? And then we can go to the two-way ANOVA. Is this okay?
Yes, sir.
Okay. So next, what we want to ask is that if so the next question that you can ask is that, say you were comparing two different, like you were comparing one variable and wanted to figure out if it depends on another variable. So here what we are doing is that our dependent variable was HP and independent was the number of cylinders. But now you come up with an even better question. You are asking if the HP, does it only depend on the number of cylinders a car has, or are there more variables that can affect the HP? So that is the question. So you are asking if there are two independent variables can affect the dependent variable, and do those two variables interact with each other to affect the variable. So that, in order to figure that out, you use the two-way ANOVA. The questions that you ask is that pretty simple, straightforward. The first two are pretty straightforward. Is that you have two different variables. How does the HP depend on the number of cylinders? How does the HP, or here we are dealing with mileage, how does the mileage depend on the number of cylinders? How does the mileage depend on the horsepower of the car? So this is same as what we are doing here, just two at a time. And the third question is what the two-way ANOVA shines on, which is there an interaction effect between the two? Are they two of them coming together to produce something more? So is it that A by itself does not have an effect, B by itself does not have an effect, but two of them together are actually having an effect on our dependent variable? In that case, if you wanted to figure out if our mileage depends on the number of cylinders and the HP together, then you run the test like this. The next question that we had was we figured out that the HP doesn't matter to mileage because HP and mileage did not have a significant value, and cylinder and HP both didn't have a significant value. We then wanted to ask what else can it depend on? Maybe the displacement the car is showing. So what we did is that we ran the test like this. We wanted to figure out if mileage depends on the number of cylinders, which actually gave us a significant result. The second question is does mileage depend on the displacement, which also gave us a significant result. Does mileage depend on both of them together? That is, there is an interaction between the two of them that causes more than the normal effect. That also was significant, which shows us that together cylinder and displacement both play a role in determining the mileage of the car. So this is the type of question that you can ask using a two-way ANOVA. Is that fine? No, still goes over the radar. Hello?
স্যার একটা কোশ্চেন ছিল,
বলো বলো।
দুটোই কেসে যখন আমরা কম্পেয়ার করছি সিলিন্ডারের ভ্যালু আলাদা কেন বেরোচ্ছে দুটোই কেসে? একটা তো একই বেরোনোর, লাইক ডিপেন্ডেন্সি তো একই হবে।
That is a good question. That actually, so when you're running a two-way ANOVA, the formula actually differs depending on the third variable you are adding. So displacement যখন অ্যাড করছি তখন একটা চেঞ্জ হয় ফর্মুলাটাতে, বাট সিন্স উই আর নট ডিলিং উইথ ফর্মুলাস দিস মাচ, তার জন্য এটা এখানে দেখতে অড লাগছে, বাট ইট ইজ লাইক যতবার আমি থার্ড ভেরিয়েবলটা চেঞ্জ করব ততবার ইট উইল গিভ মি আ বিট ডিফারেন্ট রেজাল্ট, বাট উই ডোন্ট কেয়ার অ্যাবাউট দ্যাট। দ্যাট values that you are seeing, all of these are part of the test. The final value that you care about is only the p value, which will be significant, like যতক্ষণ ওটা 3 স্টার থেকে 2 স্টার সিগনিফিকেন্ট হয়ে যাচ্ছে না ততক্ষণ আই ডোন্ট কেয়ার অ্যাকচুয়ালি।
ওকে স্যার।
Okay, anyone else has any questions?
Sir, I have a question.
Yeah.
Sir, what is this F value that is being represented here every time we run the codes?
The f value is actually the confidence interval. If you remember last time when we are dealing with, I think, the 4th or 5th class, we discussed about confidence intervals, that the value needs to be the, when you're comparing two different distributions, you actually care less about the center of the distribution and more about the tails of the distribution, how far the value is towards one tail or the other. Not so it gives you an idea that how separate the two distributions are. So this value actually gives you the tails of the distribution. The confidence interval gives you an idea of that if the f value is further, so it all depends on what you're comparing. So cylinder, there will be a f value comparing the cylinders as well as the mileage, and this gives the f value is this actually is used in a calculation which actually divides it by the f value of, not f value, the mean of the mileage, to actually gives you this PR, the p value.
Okay, sir.
Okay, any other question? So essentially, just to clarify, the f value actually gives you a idea of the variance between the two distributions, essentially where the tails are compared to the center, and if they are further apart you have a significant result, if they are close together they don't. So we are actually trying not to go into much of the mathematics in this, because we actually just want to use the entire test as a whole to figure out what to answer our questions rather than go into how it is working. Everyone is fine with this? Okay, so going back, mm-hmm. Yeah, you can't see my screen, I guess. I'll display my entire screen. So we have already dealt with uh, if our type of data is continuous and we want to find the difference between the two data sets. If there are more than if there are two groups, we use the t-test. If there are more than two groups, we use the ANOVA. But what if your data is categorical? Categorical data indicates that there is not a continuous difference between the data. So essentially, number of heads or number of tails when you flip a coin, the number of times um, one comes up when you're rolling a dice, the preference of a particular product A or B depending on the gender of the person. This kind of data where one variable is categorical, which is not a number or not continuous variable per se. In that case, we use something called the chi-square test. So an example would make this more clear. So the first thing you wanted to so here in ANOVA you figured out if the if mileage depends on either the cylinders of the car or mileage depends on the horsepower of the car. In a categorical scenario, if you wanted to figure out if there is a test between dependency of two variables, say is one variable actually dependent on the other, which using ANOVA for continuous we have figured out that HP mileage is not dependent on HP. But what is the case for categorical variables? In that case, you use the chi-square independence test. So you figure out if two different categorical variable depends on a continuous variable or not. For example, say you wanted to figure say there were three different products, three different kind of face creams that were being sold at the supermarket, and you wanted to figure out if these face creams actually one gender prefers or the other. So you know, like you have seen in stores that most of the creams that are sold to men are charcoal, petrol, diesel, dark, white, these kind of things, whereas the one that are marketed to females are mostly rose, vanilla, pink, these kind of things. So if you wanted to actually figure out do men prefer one kind or do females prefer other kind, or they will buy anything. So to figure something like that out, we have a categorical variable, which is the gender, and a continuous variable, the number of times a particular product was bought. So here I have made a list of everything. Say product A, B, C are the three types of face creams, and the number of men and female who are buying these are given here. So the question is there a relationship between the products being bought and the gender of the person buying them? To figure that out, you use something called a chi-square test of independence. Is the product and the gender independent or not? Running that is fairly easy. You just run this function chi-square test data is our matrix that we have made, and then just display it. Displaying it tells us that the p-value. So I would like you to actually run this. So go ahead and run this first, and then we will look at the results. All of this should be should look somewhat familiar. The call names, row names, functions that we had used to describe the columns and row names to different matrices when we were dealing with in, I think, the third or fourth classes, the early classes. We have all used these, and now we are actually using them to create data sets to test our ideas. Does it run? Anyone?
Yes, sir.
So do you get a result similar to this? So here we see that the p-value is very significant, which tells us that the product choice and gender are not independent. So in this case, the null hypothesis is that the choice, the categorical variable and the continuous variable are independent to each other. And here we figure out, no, they are not independent to each other. They are actually pretty dependent because the p-value is significant. So our chi-square independence test shows us that they are not different from each other. Is that fine with everyone?
No, sir, if you could explain once more.
So in chi-square independence test, we have one set of one variable which is continuous. Here the variable is the number of times a particular product was bought, and the other variable is categorical, which is the gender of the person that is buying the product. We wanted to figure out if these two are independent, that is, it doesn't matter which product is being bought, a man is equally likely as a woman to buy all of these products. So that is why we ran the chi-square independence test. The does do men and female women prefer buying one product over the other? So is there a dependence between the categorical variable and the continuous variable? And when we ran the test, we found that the p-value was significant, which shows us that the categorical variable and the continuous variable are not independent. That is, depending on the gender, they are preferring one product over the other.
Okay, sir.
Clear it a bit? No. Okay. Say we wanted to run the same test on our empty cast dataset. What do you think is a categorical variable that we are dealing with for so long? In the previous class also, we are dealing with the categorical variable cylinders, right? It was a factor variable which is the same as categorical variable. It is not a continuous variable. It is either 4, 6 or 8. So if we wanted to figure out the relationship between is cylinder number of cylinders dependent on the something else, say we figured it out, it is dependent on displacement and HP. If we wanted to figure out if it is dependent on the weight, so the question is, let me write it down here. If I wanted to figure out if the number of cylinders of a car is independent of the weight of the car. So we can again use the chi-square test for here. Chi-square test of independence. So can anyone, like, you guys please go ahead and try and figure out how we will run this. So again, the empty cast data set, the variables that we are the variables we are dealing with here are the number of cylinders and the weight. We can even figure out it between the mileage, and actually mileage and weight would make more sense. Oh no, mileage and weight won't, because we are it is a chi-square test, so you want a categorical variable. So cylinders and weight is something that we want to figure out if they are independent or not. So you guys can go ahead and try running this chi-square independence test on this empty cast data set, cylinders and weight, and try and run it. And if the code runs, please let me know, send it in the chat, let us all see how you're running it. So if you remember, the first thing about, if you do not know about a particular function, the first thing you can do is that just ask for help. You can go ahead and put in the name of the function, which is chi-square.test, and it gives you how to run the function. And from there you can figure out how exactly to run the code to ask the question that you're asking. There are examples as well on how you can run it. There is a lot of help around. So let's see who can do it first. Was anyone able to do it? Yeah, meeting has just 15 minutes left. I will make another one. New meeting, create. No, what happened? Start instant meeting. Yes, this is what I want. I'm sending it into the chat. Please make sure you have copied it, and please join after this one closes. Uh, is anyone trying? You should be able to do it. We have been doing a lot of difficult things. This is pretty easy.
Yes, sir, it ran.
You ran, and what did you find?
So the table is coming, and the Pearson's chi-square test, the data values are coming.
And the p-value is significant?
Yes, sir. 0.35 something, it's coming.
0.35.
0.353. 0.353.
So is that significant? Is that significant or not? 0.35? Let me try running it. It should be a matrix x equal so we are doing it between cylinders and the weight. It should run. It has run. And if I do this,
Yes, sir. Now I'm getting the p-value 0.002817. Actually, earlier the data was taken as 10, 20, 30, then 25, 35, 40. Now I've put on the correct order of data and I'm getting the same p-value.
okay, that's nice. Okay, no, I did not understand. Can you show me your screen? How are you getting a significant p-value?
Okay, sir. Okay. Yeah, go down where okay, you are doing it with the you're making the data set again and trying to do it, right? Okay, so I thought you were trying between the weight and the mileage, weight and the cylinders that we are talking about. So that is not significant because it is 0.35, and as we know that it should be It's,
0.05 or lesser to be significant. Yeah, go ahead.
okay.
Okay.
Sir, shall I now stop presenting?
Yes, you can. Okay, so yeah, as we see, the weight and the cylinders both are not significant, so they are independent, is essentially what the test tells us. The weight does not depend on the number of cylinders. Okay, so that was a chi-square test of independence. The next type of chi-square test that we can use is called the chi-square goodness of fit test. So chi-square goodness of fit test. In this case, you actually try and figure out if you know, say last time we were talking about if heads and tails and the number of times the head or tails occur, that if it's the coin is fair or not. If we take the same example and try to figure out if our uh, we are rolling a dice and we had obviously six faces, and one comes up three times, two comes up once, three comes up twice, 4 comes up once, 5 comes up once, and 6 comes up 2 times. So you have rolled the die 10 times, and this is the number of times you see the number of faces. And you now want to figure out if the dice is fair or not. So in this case, you have a categorical variable and you know the expected frequency at which all the faces should come up. Expected frequency of all the faces coming up is obviously 1 by 6. So is your die actually working well, or is it like a shady person has handed you a die and you wanted to figure out yeah, so my like one of the numbers is not always not coming or something like that, so you can run a chi-square goodness of fit test. So in that case, the example that I'm giving you, in that case you actually first look at the observed frequencies. So observed frequencies are whatever after rolling the die 10 times is what you are getting the number of phases. And then you run again a chi-square test. You wanted to figure out, yes, this is my categorical value, I know how much each of the probabilities should be, and then you try and figure out if it is working or not. So your expected frequency is 10 by 6. You have thrown it 10 times. Since the die is fair, it should be 10 by 6 into 6, and you run the chi-square test as the observed number of times you have seen it, divide comma the probability that should be expected. The probability that should be expected is expected divided by sum of probability. This is essentially this 1 by 6 10 times, and then you display it. Did anyone understand anything I was saying? I don't think so. So say you were rolling dice 10 times. You got 1, 2, 3, 4, 5, 6 in the following frequencies. So you got 1 3 times, 2 once, 3 twice, 4 once, 5 once, and 6 twice. So now you wanted to, but your expected frequency of each phase was obviously 1 by 6. So now you wanted to figure out, is the dice that you were rolling fair or not? So to do that you can run, so in this case also you have one categorical variable, which is the number of phases or the number on the face, and you have a continuous variable, which is the frequency, the times that the particular number occurs. So you have observed a frequency of 3 1 2 1 1 and 2, which is this, and expected is actually just 1 by 6 repeated 10 times. So rep 10 by 6 into 6 gives you just 10 by 6 is the number of times it occurs. So 1 by 6 repeated 10 times, nothing else. So when you run the chi-square, you have to run it like observed frequencies and the expected frequencies. The expected frequencies are the number of times, essentially this also will come out to 1 by 6 10 times, and then you display the result. Can you please go ahead and run this and check and see what you get? Yes. Has anyone run it? What are you getting?
Yes, sir, same আসছে।
Okay. So
স্যার আমারও সেম আসছে।
okay, so the p-value is here non-significant again, so which tells you that nothing is wrong, the dice is fair. So yes, now if you are looking at a very shady person who is betting that you will get a 6 after like you will get a 6 3 times, and he will give you a lot of money if you get 6 even 3 times out of 10 rolls, and after rolling, so 3 4 5 6 7 8 9 10, so after rolling 10 times, say you only got 2 sixes, but the number of ones was 5. if you run it this time, what do you get? So for it to be 1, so one of them should be 0. Okay. Or say you got no 6s at all, even 1 would have given you money. So it should account up to 10, 5, 6, 7, 8, 9, 10. So he said, you roll it 10 times, if you get 1 6, I will give you a 10,000 rupees. But after rolling 10 times, you figured out you didn't get a 6 any one of the times. If you then try to figure out if it is fair, then you run the chi-square test again, and still it is not significant. So it's entirely possible that you cannot get a 6 after 10 rolls. You guys understand what I was saying?
No, sir. Explain once more.
ঠিক আছে, সো সে কেউ একটা বদমাইশ লোক ছিল যে তোমার সাথে বেট করেছে কি চলো 10 বার তুমি রোল করো নিজের ডাইসটা, একবারে যদি তুমি 6 পাও তাহলে তুমি 10,000 টাকা পাবে, তুমি যদি একবারও না পাও তো তোমাকে 5,000 টাকা দিতে হবে আমাকে। তো তুমি যখন রোল করতে আরম্ভ করলে তোমার 1 পড়লো 5 বার, বাট 6 একবারও পড়েনি। সো আগেন সিচুয়েশন ইজ দ্য সেম, তোমার কাছে একটা ক্যাটাগরিক্যাল ভেরিয়েবল আছে যেটাতে হলো দ্য ফেসেস অফ দ্য ডাইস, অ্যান্ড একটা কন্টিনিউয়াস ভেরিয়েবল দ্যাট shows you the frequency the dices occur, the frequency at which the dice phase occurs. সো যখন তুমি এই ভ্যালুটা নিলে অ্যান্ড ফিগার আউট কি হ্যাঁ লোকটা কি বদমাইশি করছিল আমার সাথে, অ্যান্ড দেন ইউ ট্রাই টু ফিগার ইট আউট, তো তুমি এটার উপর আরেকবার কাই স্কোয়ার টেস্টটা রান করলে, when you figured it out, when you ran the chi-square test again, you figured out যে কি হ্যাঁ যদি 5 বার 1 পড়ে আর একবারও 6 পড়েনি, that is still fair because the probability is not significant. So you say ki ha, the person even maybe shady but he was not cheating.
Okay, sir.
Okay, everyone else is also clear with this? Any questions?
স্যার ভ্যালু যদি সিগনিফিকেন্ট আসে তার মানে মানুষটা শেডি, মানে
হ্যাঁ, ভ্যালুটা সিগনিফিকেন্ট আসলে মানুষটা শেডি। কেন? কেন কি কাই স্কোয়ার টেস্টটা দেন বলছে কি ইয়োর এক্সপেক্টেড যে প্রবাবিলিটিটা ছিল নাম্বার অফ টাইমস একটা পার্টিকুলার ফেস রোল করার, সেটা ফলো হচ্ছে না। তো মানে মানুষটা এসেন্সিয়ালি শেডি, ওর ডাইসটা ইজ লোডেড কি একটা লাইক 6 অনেক কম বার পড়ছে। সো সে ইফ উই ডিড ইট ফর 20 রোলস, অ্যান্ড 20 রোলস করার জন্য আমি কত বাড়াতে হবে, 15, 16, 17, 18, 19, 20, ওকে 1 2 3 4 5, হ্যাঁ 20। হুম হুম So see, this is what I was talking about. If you have won 15 times and after 20 rolls and no sixes, and run the chi-square, you see that the p-value is very significant, which shows that actually the dice is loaded. It is not showing the observed, like যেমন হওয়া উচিত সেমনি হচ্ছে না, তার জন্য you are getting a significant chi-square goodness of fit test. So there is some বদমাইশি going on here. Why do I have to admit people again? Should not. We still don't have enough people. So let everyone join. Then we will resume. Okay, I think enough people have joined, so I will quickly go again and show you what I was trying to show you. Okay, say that the person handed you the dice, and after rolling 20 times you got 115 times, but 6 none of the times, and he said ki 6 pull you will get a lot of money. And then you figured out ki this time there is something wrong, so you again run the chi-square test. Here you change your expected probability to 20 by 6 because you're rolling 20 times, and this time around you see that the p-value is very significant, which shows that really it is the case that the dice is not showing expected number of the expected frequency of the faces rolling up. So it is manipulated in a way ki 6 কখনোই পড়বে না and 1 সবসময় পড়বে. So this is how what you can figure out using a chi-square test. Is that fine?
Yes, sir.
Okay, so this was all about so we have actually covered the right hand side of this entire table. We figured out if we wanted to figure out the difference between two groups, we use t-test. More than two groups, you use ANOVA. If we have categorical data and we want to figure out the relationship between a categorical data and a continuous variable, and if it is independent or following a particular probability that we know it should, then we use chi-square test. Next we go down the left hand side of the ladder. If instead of the difference between two variables or the difference between two data sets, we want to find the relationship between the two data sets, then we come to correlation and regression. So these are probably the most powerful tools that you have in hand to figure out a lot of things, and we'll go into these.
স্যার এই পিডিএফটা একটু পাঠিয়ে দেবেন এই আগেরটা।
এই ছবিটা?
হ্যাঁ স্যার, এই ছবিটা।
হ্যাঁ, এটা আমি যখন আপলোড করব তখন পিপিটিতে থাকবে, আমি আজকে করে দেবো যখন।
ওকে স্যার।
স্যার আজকের ক্লাসের রেকর্ডিংটাও একটু দিয়ে দেবেন।
হ্যাঁ হ্যাঁ হ্যাঁ, আমি কালকের আজকে দুটোটাই দিয়ে দেবো, ও একসাথে ইউটিউবে আপলোড করে দেবো। ওকে, so next we are going to deal with correlation analysis. So here till now we have been figuring out yes, if there is a difference between data sets or not. Now comes the question, is there a relationship between the data sets? For example, if you wanted to figure out yes, there are two things, so the marks that you are getting in maths versus the amount of homework you have done, is there a relationship between these two? Or is there a relationship between the times you the amount of hours you exercise versus how much weight you are losing? Is there a relationship between the diet that you are following and your weight overall? All of these are relationships when you are trying to find out between two data sets, and you use correlation to find it out. So correlation is the statistical analysis of finding a relationship between two variables. It could either be positive, mane both have a positive relationship, mane the amount the number of hours you put into practice mathematics, the more marks you get, a positive relationship or a positive correlation. The other way around, if you the amount of hours you exercise is negatively correlated to the weight you have, so negative correlation. Or it could be neither, so the amount of hours you exercise versus the marks you are getting in maths, there is no correlation. So you can either have a positive correlation, a negative correlation, or no correlation between two variables. There are three types of correlation. There are three types of correlation tests that we use. First one is called Pearson's correlation coefficient, in which you investigate two continuous data, like two continuous variable, you figure out the relationship between them. The other is the Spearman coefficient, in which you figure out the relationship between a categorical data and a variable data. And final one is called the Kudnell coefficient, which is similar to Spearman, but Spearman is mostly used, so we are going to deal with that only. ঠিক আছে, So see what. So going back to our empty cars dataset, say we have been figuring out the difference between the 4-cylinder and the 8-cylinder cars and the HPs that we have, the horsepower they have. But say I wanted to do something else. I wanted to figure out if my mileage actually is correlated to my HP or not. So how much mileage my car gives and how much horsepower it can produce, is that correlated? If I am trying to find the correlation between two continuous variables. So in that case I will run the function core test and followed by the first variable and the second variable. As easy as that, and then print the result. So go ahead and write these lines down and see. So prothometa darkar nahi, prothometa just was to see what so it remove polygashment. Run these two and see what you are getting. হয়েছে চলছে
Yes, sir.
So you should find a Pearson correlation like this, in which you are looking at two different things. First, the p-value. So if the p-value is significant, means that the whatever the correlation gives you is significant, and the correlation is this value, the correlation coefficient. So the correlation coefficient can go anywhere from -1 to +1. If it is towards the -1, then it is negatively correlated data. Positive এর দিকে positively correlated data. 0 আশেপাশে ঘুরলে then they have no relation between them. So here we have a negatively correlated data with a very significant p-value. So it is negatively correlated and it is significant. So that tells us that the mileage and the horsepower of the empty of all cars are actually negatively correlated. যত বেশি horsepower তত কম mileage, which makes sense. The more powerful the engine, the more petrol it will consume, which also, so this is how you use correlations. So you find the relation between two variables and you actually get a mathematical output for it. So this is very well visualized in a form of a graph. So you don't have to write this down. I will just display this for you. You will get it when I will share the R notebook with you. So this is just I am plotting my mileage versus horsepower, and you see that the mileage versus horsepower, when I plot it, there is seemingly is a straight line going through it like this. So most of the time correlation, when you are dealing with correlation, you don't so when you are dealing with correlation, this line, the correlation coefficient is essentially the slope of this line. You can see the slope is negative, so minus, if you figure it out, it will be minus 0.7, as we saw in the correlation coefficient. So correlation coefficient holo slope of this line, which shows that with mileage decreasing, the HP increases. The HP increases when the mileage decreases. Is that okay? So using correlation, you figure out the relationship between two different variables. Here we see a negative relation.
Sir, since the correlation is inversely proportional, is that why the result came as a negative?
Yes, exactly. Inversely proportional by negative. If it would have been directly proportional, though, it would have been positive. So as you see, so seeing this result tells you mathematically that they are correlated. Seeing this result, you are able to see it would have been negatively correlated even if I would not have seen the actual tested correlation coefficient. So that is also a good way to figure out if two data points are correlated. You plot a graph between the two of them. So plotting graphs is in R, we have already done it. So there is a pairs function which plots scatter plots between the two graphs, between two different variables, and here we want to figure out scatter plots of mileage versus HP versus weight. And if we actually do that, we see that mileage versus HP, you actually see a negative correlation. Mileage versus weight, negative correlation. So mileage reduces with increasing HP, mileage reduces with increasing weight. HP and weight actually have a positive correlation ish. এইদিকে দেখা যাচ্ছে এটা mileage and weight again negative, HP and mileage again negative. So pairs function can give you easily multiple scatter plots that you can actually look at and see if it feels like if they are correlated or not. But this only gives you a feel for it. What you actually want to do is that figure out if they are correlated using the test itself. So ekhan theke, even though it looks like it might actually not be true. So the function, actually useful function, is called cor plot. It plots the correlation between all variables in a data set. So since it is a very powerful function, you can use it in a huge data set. So if I do it for empty cars at once, so if you guys can try and run this, go ahead and run this and see what you are getting. রান হয়েছে? হ্যালো,
Yes, sir, হয়েছে.
okay, so you should see a beautiful graph like this. So this entire table actually shows you the correlation coefficient of all the variables that you saw. So mileage and number of cylinders has a minus 0.85, displacement and mileage has a minus 0.85, HP and mileage again minus 0.85, DRAT and mileage 0.68, weight and mileage. So this actually gives you at a glance all the correlation coefficients throughout the entire data set. একবারে হয়ে গেল. So you know which one are positively correlated, which one are negatively correlated. Even this function gives you it color coded to you. So blue is positively correlated, the darker blue the more positive, the darker red the more negatively correlated. Or white at dige there is no correlation between the two. So probably both of them are independent variables. So for example, যেমন DRAT and QSEC, both of them are independent. VS and gear, both of them are independent. AM being I think the automatic or manual transmission, and I don't know this gear, oh no, not this carburetor, if it does have a carburetor or not correlated at all. So here at once you are able to figure out if two variables are correlated, so if they have positive correlation or negative correlation. But there's one thing that this graph does not give us. Can anyone guess what it does not give us? So when you're looking at correlation coefficient or any other test, there is one important thing that we always want to see. It is not here. Which is it? কেউ গেস করতে পারবে? So we have only seen that we only care about here during correlation coefficients. We only care about two things: if there is a correlation and the p-value, right? The p-value is also not present in this graph. So to figure out the p-value, you have to run this function rcor, which takes matrix inputs. So we convert empty cars as matrix and just run it, and you see a huge amount of p-values here for all the different things. So all of them. So all of them, you first look at the coefficient and say yes, mileage actually is negatively correlated highly with cylinders. Then you go here and find mileage and cylinders. You see the p-value is very, very significant. So that tells you that yes, the correlation is negative as well as the p-value is significant. So it is actually negatively correlated. Everyone with me so far?
স্যার একটা এরর দেখাচ্ছে, there is no package called call plot.
No package called call plot. Have you run? So you have to install packages call plot. I have commented this because multiple times I didn't want to install. So if you are running it for the first time, you run it without the hashtag. It should install and then run the entire code. Similarly with the HMISC package, you first have to install it. So without the hashtag, you run it and then it should run. Everyone tell me, is this fine? Like we are on the same page regarding correlation of an entire matrix at once? You can even tell me if you are understanding or not. Is that too complicated? Yes, no. ঠিক আছে, কোনো problem? Anyone problem understanding? Are you getting it or not? Please tell me. বুঝতে পারছো? Yes, no, কিছু. Give me something, please.
Yes, sir.
Okay. So here is a big discussion about correlation, and there is a difference between correlation and causation. So whenever we are saying that two variables are correlated, say the number of hours you have practiced mathematics versus the marks you have gotten in mathematics, both are very well correlated. Okay, but that does not tell you that they are causative. Causative meaning that number of hours that you're studying mathematics actually is causing your marks in mathematics to grow. Correlation only tells you if the variables have a positive or negative relation. They do not assume causation. For example, say that someone is telling you that if you were able to plot a correlation between the size of your shoes versus the class that you are in school, so you should actually see a positive correlation, right? The bigger that your shoe size is, you are the higher class you are in school, so both of them are correlated. But that is not causative, right? Actually your size, shoe size as well as your class is increasing because your age is increasing as you go along. So correlation gives you an idea if two variables are positively or negatively related. It does not say that yes, because one like the variable x is increasing, it is causing the variable y to increase. So for example, as I said, the example is just that. Sometimes there is another example here. Take for example the correlation between the price of consumer products such as milk and its consumption. It is obvious that there is a link. If price of milk increases, its consumption will decrease. So here there is a causation, but in correlation does not by itself suggest a causation. Is that fine?
Yes, sir.
Okay. So next, so we have dealt with Pearson coefficient when we are dealing with correlation of two continuous variables. But what if one of your variables was a ordinal or a categorical type of variable? In that case, you use the Spearman coefficient. In case of Spearman coefficient, you use the same code or the same function chord.test, and in our empty cast data set, the categorical variable was cylinder, right? If you remember 4, 6 or 8 cylinders, it is categorical and not continuous, versus the mileage, and you wanted to figure out if there is any correlation, and you run the same test again, and it gives you a significant p-value and a negative correlation. So your mileage is hugely negatively correlated to your number of cylinders. This is what the Spearman coefficient gives you, relation between a categorical data and a continuous data point. And then if you plot it, you actually see the negative correlation as a negative slope of the entire line. You see it goes, so it goes negatively down. So as the number of cylinder increases, the mileage decreases, which makes sense. But again, it does not tell you about the causation. See, as we have previously seen using ANOVA, the actual relationship between mileage and the car's strength is the horsepower. As the horsepower increases, the mileage decreases. The cylinder is essentially contributing towards horsepower, which is why both of these are negatively correlated. The cylinders by itself are not decreasing the mileage. So this is what we meant by causation versus correlation. So that was all about correlation. Does anyone have any questions?
No, sir.
Okay. Now next we go into an even more powerful statistical test called regression. So correlation just tells us if two variables are related. It does not imply any solid link between them. So it tells us yes, the number of hours you're practicing mathematics is correlated to the marks that you're getting in mathematics. But if you wanted to actually find out a mathematical relationship between the two, like a solid relation, like what is the exact mathematical relation, or can I predict if I studied 5 hours how much marks I will get versus if I studied 10 hours. So when you want to find a concrete relationship, or you want to predict one variable depending on the other, then you used regression. So regression is it is a bit different than correlation. As you see, it gives a concrete relationship between two variables, and in regression you have to describe a dependent and an independent variable. So something depends on the other. It is the idea behind regression. In correlation, you are just correlating them. You are like, yes, this increases, this increases, this increases, this decreases. But in regression, there needs to be a solid relationship that you know beforehand, and you want to figure out that solid relationship. So in this case, essentially I will show it to you what this looks like. Yeah, regression actually gives you, when you run regression, actually it will give you a equation such as this between your dependent variable and independent variable. So x here is the number of hours that you have studied, and y is the marks that you get in mathematics. So essentially you have a solid concrete equation relating the two variables using regression. So how do we go along this? You say, actually I want to figure out the regression line. So when you do a regression analysis, you find a regression model or a regression line to predict the relationship between two different variables. So we are again dealing with our empty cars data set, and the first kind of relationship regression model we are going to look at is called the linear regression model, in which you expect there to be a linear relation between them. Linear relationships mean that the two of them can be written in an equation like y equal to mx plus c. So essentially you imagine there to be a straight line equation between the two variables. So in this case, the function that you use to figure out this regression model is called LM, linear model. Same formula as we have seen before. The two variables are mileage and horsepower, and the data set is empty cars. Go ahead and run this and see what you're getting. Hopefully that was something, someone is getting something. So regression is essentially just plain old mathematical magic. You are able to figure out a relationship between two different variables. So here, so the data point should, like the result should look like this. Here what you care about is the intercept. The intercept and the HP coefficient. So essentially intercept we know from old graph theory, C is the intercept. So C is intercept, M is the slope or coefficient of independent variable. So it gives you the intercept as well the estimated coefficient of HP. So your regression line should look something like this: y equal to minus 0.06823x plus 30.09886. So essentially you predict a model, you generate a model depending on the data you have, and using this model you can actually predict, depending on how much HP your car has, how much should the final mileage that your car gives is. So essentially you have figured out a solid concrete equation to relate HP and mileage. If you plot it, you will get a plot such as this. Again, you see a negative correlation, or here you call it a negative regression coefficient between the two variables, HP and mileage. Everyone with me so far?
Yes, sir.
Okay. Yeah. Wait. We will rerun this. No, we have moved into this part is the logistic regression. Okay, so using this data, you actually this is also logistic regression. Sorry, here is when logistic regression starts. Okay, so you have here the linear model is not just for looking good, it actually can also predict stuff for you. So give me, so you have actually predicted this model and you want to use it to figure out the mileage of any car, depending you know the horsepower of the car. So to do that, you will use a function called predict. So you guys can actually just write this down and use predict. So I will write down what I mean. Using the linear model generated between MPH and HP, use predict function to predict the horsepower of not the horsepower, the mileage of a car having 250 HP. So what should be the mileage of such a car? So it will so since we have already made a linear model using LM function, you just have to use a predict function on top of it. And how to use a predict function, you can look it up using help, and you can go ahead and try and predicting what the mileage of such a car is. So just to show you, this is the code that you have to write first, and using summary, you first write these two lines of code and then you use the predict function to predict the mileage of a car having a 250 horsepower. You can go ahead and try that out. হচ্ছে কি করতে পেরেছো? হ্যালো, বোঝা যাচ্ছে না নাকি? হ্যালো, কেউ কিছু বলো। আর ইউ এবল টু ফিগার আউট হাউ টু ইউজ দ্য প্রেডিক্ট ফাংশন?
স্যার একটা জিনিস এসেছে,
হুম, ঠিক আছে, আমি বলছি কীভাবে করতে হবে। প্রেডিক্ট, so using predict, if you have read all of this, you can actually know that you have, first thing you have to input is the linear model that you have created. So the linear model, our name of the linear model is linear model, comma, the second is what you're trying to predict. So the second is the independent variable. The independent variable you have to put it in as a data frame, and our data frame consists of just one thing, which is the HP, which is 250. So if I run this, एक second. Is it not a, if I put it just 250, then it should be a data frame. I'm putting it as a data frame, and it is giving me object HP not found. Okay, where is the error? If I just not do it here, if I do it out here, yeah, the mileage of such a car should be just 30. Did everyone understand this? Are we on the same page, guys? Hello?
আস্তে রান করছে না।
রানি করছে না কেন? Are you not inputting it like this? Does someone want to share their screen and show me what the problem is?
স্যার প্রেডিক্টটা একবার শো করুন ওই সেন্টেন্সটা ওই কোডটা
হ্যাঁ হ্যাঁ দেখো, predict followed by the linear model that you have generated, then a data frame which has your HP value that you want to use to predict.
হ্যাঁ স্যার হয়ে গেছে
Okay, so essentially using regression you find a concrete relationship between two different variables, and then you can use the linear model that you have made using regression to predict different values depending you know what the independent value of your variable is. So this is how you do it. So ঠিক আছে, so this was
স্যার রেজাল্টটা বুঝিয়ে দেবেন
হ্যাঁ বলো।
স্যার বলছেন প্রেডিকশনে যে রেজাল্টটা বেরিয়েছে ওইটা একবার বুঝিয়ে দেবেন
হ্যাঁ, সো আমরা প্রেডিক্ট করছিলাম কি mileage and HP এর মধ্যে we wanted to find a relationship, and it predicted this huge model that was done. And when I put in, so my independent variable is HP, so when I put in my value of HP, it actually predicts a value of mileage.
ওকে স্যার
So it is just ki ami HP I essentially wanted now can actually figure out what the value of any mileage is depending if I know the HP. So essentially I have, so we are in the age of artificial intelligence. You have heard of how you can ask AI any question and it will give you an answer depending on the training it has got. So using this data that we just from the empty cast dataset, we have actually trained the regression model, and using the regression model we can now predict stuff depending on what we input. So this was about linear regression. The other kind of regression that can occur is called logistic regression. In this case there is one bivariate data, either true or false or 1 or 0, and there is an independent what do you call it, an independent continuous variable. So say in this case, so in the previous case we had two continuous data points, datas, and in this case we have one bivariate data, true or false or independent continuous variable. So like, are you going to pass or fail depending on the marks you are getting? Can you make a regression model depending on that? So here we have done just that. We have first we are again using empty cast dataset, and we are looking at another factor called AM, which is automatic or manual transmission. And using that we have, after a lot of these things, actually I will run all of these. Okay, I have not run something. I will share this example with you in the R notebook itself, so it is pretty complicated, but essentially I will show you how it looks like. Not this, not even this. Take it. I don't have an example here. Very good. So essentially logistic regression is the same as linear regression, but one of the variables is bivariate, and like pass and fail, true or false, 1 or 0, another is independent. But you will have to run it on empty cards, you will have to go through a lot of things to actually make it into a bivariate true and false dataset. So I have tried doing it, but it's not working. So I will probably later on give this to you in the R notebook. So so this was about regression and correlation. Does anyone have questions from today's class?
No, sir.
Okay, so this essentially ends the second module for our classes. In the next week's class, we will start with inferential statistics, which is a bit more easier than what we are dealing with here. So it will most of the time just be essentially probability and how we use probability to describe different data sets. So that is all for today. If no one has any questions, then I will say goodbye to you today, and I will see you next week. And probably most probably I will have an assignment for you that I will give you middle of the week that you will have to do based on the first two modules. And please, if you have any questions regarding any of this, please let me know so that we can solve it before I give you the assignment. So you can text on the WhatsApp group or send me a mail, whatever you want.
Sir, will it be a group assignment, and if it is a group assignment, will the group division be by you?
Group division. What do you guys want to do?
মানে
If you
আমরা নিজেরা করে
I
নেবো
will
না
ask
আপনি
you
করবেন?
like directly, if you guys want a group or if you want a group assignment or a single one person assignment. People who are for group
Single.
assignment, you can just put your thumbs up, I will count, and we will have a democratic thing here. Group assignment people, put your thumbs up. For now there are 2 3. Joldi, the meeting will end. Whoever wants to put their
থামস আপটা আসছে না।
thumbs up কেন আসবে না, সব আসবে, তুমি করো. We have 5 6 again 5 compared to 37. Okay, most of you want a single assignment. Okay, you have 10 more seconds.
I think they are not raising the hand, rather they're just putting the thumbs up. I think that raising the
Okay.
hand should be a better
Ha
prompt.
ha ha. Raise your hand. I'm sorry. I meant raise your hand because thumbs up I cannot count. Sorry. Raise your hand. Okay, so you guys win by a landslide. There are 21 people raising their hands out of 37. So yeah, we will have a group assignment. And do you want me to make a Saprativa is like, I want a group assignment, I will not do it alone. He has a 50 thumbs up, one after the other. Okay, and I think I will make the groups to make it fair to everyone, otherwise you guys will clump up together. I will make the groups and I will make it very democratically, and I will share you what the groups are, or if you I think I will do it.
স্যার গ্রুপসটা আমরাই বানাই, অ্যাকচুয়ালি সেকেন্ড ইয়ার থার্ড ইয়ার মিক্স হয়ে গেলে একটু চাপ হয়ে যাবে।
তোমরা বানাতে পারবে এটা কনফিডেন্টলি বলতে পারবে আমাকে ওয়েডনেসডে অবধি? দেন আই ওয়ান্ট the entire list. So I have 60 people in the entire class, but I think only 35 to 40 people are attending regularly. So I want groups of 5 people each, I think would be the best. So I need 8 groups by Wednesday. If you guys can make 8 groups, 5 people each, and send me a WhatsApp link, like WhatsApp group and you send these are my group members, 5 people each, and you are able to divide 40 people accordingly, well and good, you guys win. You will have your groups by Wednesday. By Wednesday, if I do not get 8 groups with 5 people each, then I will make groups. Is that fair? রাষ্ট্রপতি দেবা is again thumbs up. Okay, ঠিক আছে. So that is what we have. I need 8 groups with 5 people each by Wednesday, and then I will share you the assignment. I will make 8 different assignments for the 8 different groups and share it with you. Okay everyone, thank you for joining. I will see you next week. Thank you.
Thank you, sir.